Welcome to Study Loop.
In this question, we have a smooth sphere of radius r. It's made to translate with a constant acceleration a is equal to g. The particle is kept initially at the top of the sphere and released from there with a velocity equal to 0 with respect to the sphere. We want to find the speed of the particle with respect to the sphere as a function of the angle theta as it slides down. So in this diagram, we can see the particle at the top of the sphere and we can see the particle as it has slid down. We know that the force acts on the sphere towards the left, so the particle experiences a pseudo force equal to ma towards the right. The initial kinetic energy of the particle is equal to 0 because it starts with 0 velocity. As a result, using the work energy theorem, we can say that the initial gravitational potential energy is equal to the final kinetic energy if we take the final position to have 0 gravitational potential energy. We can also work out the change in height, thus the change in gravitational potential energy, by resolving the components here as seen, so that we can say that the change in height, so h, is equal to r 1 minus cosine theta. We also know that this distance between here is equal to r sine theta, as it's the opposite component to this angle. So what we can say now is that the work done by gravity is equal to Wg, and the work done by the pseudo force is equal to Wf. We've got this, and we know that this length here is r sine theta. So what we can say is that mg multiplied by the change in height, which gives us the gravitational potential energy and can be seen by this expression here, so times r 1 minus cosine theta. And because this acts in the same direction as the force, we can add the force, so ma, due to the fact that F is equal to ma, multiplied by the distance it travels in that direction, so r sine theta, and equate this to the final kinetic energy, which is equal to 1/2 mv squared. Now we have this expression, we can simply rearrange this and solve for the velocity. So the next step is to simply take these factors out and cancel it down so that we can get the next expression. We know that a is equal to g as it's stated in the question, so the next expression we get is the mgr, so the common factors taken out, and then in brackets 1 plus sine theta minus cosine theta is equal to 1/2 mv squared. We can see here in this expression that the mass is a common term, so it can cancel out. And now rearranging this to obtain v squared and then square rooting both sides, we get a final expression that says v is equal to the square root of 2gr multiplied by 1 plus sine theta minus cosine theta. And that is our final expression for the velocity.